Yes? Okay. Let me come out to you. So, hi everyone, I'm Till. And I'm exceedingly happy to present something that we've been working on for the last, half a year at least, and plotting and scheming on before that. This is about showing you what the state of the KDEPIM applications on mobile platforms is. So, I'll talk about what we're doing. I mean, isn't everyone doing PIM on the cloud anyhow? Right? Isn't there already a nice working mail application and a calendar on the MyImo platform? Why the hell are we doing this? Why are we doing it? Why do we think it's important to do it? And why do we think the world needs KDEPIM on mobile? How are we doing it? That'd be interesting for you guys. How many programmers in here? Awesome. And then I want to talk about how to get the Finns involved. I hear the best way to get them involved is to get them into a sauna. So let's see about that. Random slide. This is actually what I feel like after last night, because we had to take a bus to come here. The plane had to turn back around. So. Anyhow, let's talk about the why. Well, this is free software because we can, damn it, right? People have fun doing it, so let's get cracking. But this is the more important bit. We actually think that you should want it all. You should want to have all of the stuff that we have on the desktop in the PIM area available on your phone. You should have all of your data offline available. You should be able to search through it. You should be able to tag it, link it. You should have all of your encrypted email. You should be able to quickly and securely search through it. You shouldn't have to make any compromises. The N900 is more or less, well, it's a Linux box, right? It's not that far away from a small form factor laptop. So why are we making all of these compromises on the mobile platform? Well, people traditionally say, well, it's hard, right? It's small. And, So being the optimists that we are, we take the approach of Freddie Mercury here and say, we want it all. Let's at least try if we can have it all, right? So what are we doing? Well, I figured I'd start with a demo because that's the bit you're interested in, right? Unfortunately, they have no plug for me, so what I have to do is I have to start this proprietary application here in the hopes that I can actually show you something. Let's see if this works. Okay, it's upside down, but you can kind of almost make it out. Should I be closer? I don't know. Well, now this is getting to be a real challenge. Okay.
Isn't there an effect?
It's inverted? Yeah, well, that's because it's supposed to be used for taking pictures of yourself, right? So it's supposed to work like a mirror. Clever Apple people. Okay, this ain't working, is it? Well, no. Okay, well, let's skip that bit. You'll have to come and look at this. Actually, even better. You can install this. There is a repository, an apt repository on files.colab.org, and you can go and install the applications because they're actually out there. We've pushed them out at Linux Talk for everyone to go and see and play with them and give us feedback. I use it. This is my real phone for my real work email and real work calendar. It hasn't lost data yet, so let's hope it keeps that way. So it is actually at least approaching usable, and I encourage you to go try it out. I'm sad that I can't show you, but this isn't working out. So what we're trying to do, as someone put it, is to try and parallel park an aircraft carrier on a stamp, right? We have this huge thing. Who thinks contact is big? Who thinks it's too big? Nah, come on, guys. It's a monster, let's admit it, right? There's a lot of stuff in there. Do we actually need all of that? How do we transfer that to the phone? Do we want to transfer that to the phone? So that's what we're trying to do. Well, here's how we want to try and do it. Obviously, we have this beautiful thing called Akunadi, which we've been working on for, well, 5, 6 years now. The idea being that we take all of the hard bits about PIM and we put them into a server that everyone can then connect to and get the data that they actually need. So all of the hard bits are in here. And since we knew that this day would come, we've actually, while we were designing this, thought about the mobile use cases and made sure that what we build there for the desktop will actually transfer nicely to smaller form factors and resource constraints systems. So we had this kind of already. Putting it on the N900 was actually not that big of a deal, right? That went pretty smoothly. So right now it's running on the N900 using MySQLD, Virtuoso server, Nepomuk server, actually several of them. And it's just fine. It doesn't drain the battery considerably. I can use it the full day just like I could before. A full day is great, right, for a smartphone. So we apparently haven't made any huge mistakes in terms of resource consumption, and we haven't even started profiling and optimizing it yet. So we think we're not, that bad in that area. For those of you who've never heard of this is what Akonadi does. You've got your stuff out there on the cloud, right? The evil interwebs, that's where everyone keeps their stuff these days. Actually, they just give it away to other people. Does anyone feel bothered about that? I am. I'd rather have it wherever my devices are, right? Wherever I am, wherever my laptop is. So Akonadi pulls all of that in. It can read and write various formats and various storage formats like IMAP or a vCard file. And then, of course, you have various things, getting that information from the server. And because basically you can't be online all the time, although they've been telling that we will be online all the time to us for many, many years, still not the case today. So we have a cache, which is a database, and that actually keeps the stuff that we are currently working with around so we can get to it faster. It's really quite simple.
So the blue ball is in the cloud or on the device?
No, this is a server running on your device. And it's the aggregation point. It's kind of an orchestration and aggregation point, and a central cache access point. It does go out to the file system, obviously, because the database ends up writing stuff to the file system, and we don't put everything in the file system. Big files go straight to the file system. For the techie inclined, for the actual control stuff, so how you trigger things, how you trigger a mail check, and how you request online status and things like that, we use dbus. Obviously, that's what everyone uses these days for these kinds of things. Kind of the low latency control traffic, the triggering, the canceling, the progress reporting. For the data throughput, we use something that is better suited to that, because dbus isn't, and quite frankly, that's in the design of dbus from the start, that it's not suited for high traffic. So we took the thing that we knew, which was IMAP, and we hacked it up and made our own protocol that is only used for the high throughput data transfer between the application and the server. That way we can cancel while there is a big transfer going on, for example. So, getting to the mobile side of things. Blue boxes. At the bottom, you've got the server, right? Running on the device, doing all the fetching and all the aggregation and all the orchestration. On top of that, we have an access library called libakonadi. Currently, that uses Qt, obviously, and a bunch of KDE stuff, because that's nicely available, and that's what we want to do it for anyway. Then we have libraries. We've been splitting out libraries from Contact for years now, right? It started because there was an alternative email application called Mailady, and it wanted to use bits of our stuff. So we started putting all the things that would be shareable into little libraries. And we've been going down that road for years now. So at this point, we have a bunch of nicely separated libraries that deal with various aspects. So there's a library for showing an email. There's a library for opening up a composer. There's a library for showing a vCard, et cetera, et cetera. There's one that manages transports, so sending out emails. There's one that manages identities, et cetera. And then we take the desktop applications and we implement them on top of these libraries. So they actually become pretty thin layers on top of these split out libraries. Of course, there's just a lot of desktop-specific stuff in the application still, right? The use cases are different, the workflows are different, so you have to do stuff specifically for the desktop. And that's the left-hand side. On the right-hand side, we've re-implemented the UI completely. So we've taken that stack and we said, okay, mobile obviously is different. If you start Kmail on an N900, which you can, the desktop version, you get about, I don't know, maybe 2.5 millimeters of usable space so you can actually see the email. So obviously that won't work. And we said, well, we might be able to have like a mobile mode where we hide the folder tree, do magic to make that work on all platforms. And very quickly we decided, well, that's not going to work, right? We need a new UI, we need a new interaction concept, and it needs to look spiffy, because on the phone things look very different than on a desktop. So right at that point, Matthias and his gang of merry fellows introduced this awesome thing called QML, which is actually exactly tailored to this kind of use case. You make a mobile-specific UI or even a device-specific UI. It's a thin thing. It can be tailored to whatever the device needs, and then you plug it into your backend that you already have. Now, that's the theory, right? In practice, we are experiencing, or have been experiencing, let's put it mildly, some early adopter pains. Fair enough, unreleased alpha versions of stuff. Hey, that's what we're in this for. We like pain. So turns out QML obviously is still evolving. It's maturing. It's actually maturing quite quickly now, so we're converging on stable. But we've learned a lot about QML and how to integrate it with rich applications, things that aren't little demo things that play one song, but actual real-world heavy-duty applications. I don't think actually this has been done before. QML has traditionally been used so far for shiny, flick list, right? So we're very much pushing the boundaries of what's possible with QML today, and it's actually, the feedback that we give them is being incorporated, so that's very nice. As usual, Qt being extremely cooperative in that regard. So then the way we do it is we have tools. Some of you might have seen Akkonadi console on the desktop. That's kind of a debugging interface to the Akkonadi server, so you can introspect what's going on, you can watch the protocol traffic, you can see the debug stuff. Now on the device, obviously, you can't launch this thing. Well, you can actually, but much like with Kmail, it's not particularly usable. You actually have to drag the splitters around to even see anything. So Volker right there had this brilliant idea of writing this little thing that runs on the device and forwards and proxies all of the interesting traffic out to a desktop. So we have this thing that we call the Akkonadi Remote Debugging Service. Actually, I don't know. You have the right to name it whichever way you please. And what that does is it runs on a device. It's very, very small, and it just forwards the sockets, basically the dbus traffic, the Akkonadi protocol traffic, anything interesting out to a desktop, so you can attach this guy to the session running on the device, and you have all of the introspection, all of the debugging, all of the debus that you would want. This is actually, and that's why I'm showing it, of course, possible for other stuff. You can run this thing and introspect any dbus-enabled application, or in fact, actually explore the Mayhem or the Migo platform, because there's a lot of dbus on that thing, right? So if you've ever wanted to have a big dbus tool connected to your device, so you actually browse around and discover all the interfaces, there's your guy. It's in the Akkonadi SVN repository, and if you want to use it, ask for it. Yep, that's the console showing debug output. I mean, this is obviously pretty nice because you can really see what's going on. And especially on the device, you can use it for profiling, and you can really dig down and figure out what's going wrong if something's going wrong. Yep, job tracking, so you see which jobs are started, when they come back, if they had an error, all of that. So very, very extensive logging and debugging infrastructure there. What's different in mobile other than the form factor? Anyone? Come on. Who works on phones here?
The size of the display is
Display size, right. What else? You've got little of everything, right? Little display space, little RAM, little CPU. You can't actually use the CPU because then the battery will drain. So, yep. Big fingers, right. Take this one, for example. Unusually and overly big. So, yeah, you've got users using this thing in much different situations than on the desktop, and you have very constrained resources. So the solution to that usually is, at least part of the solution is caching, clever caching, right? Making sure you have just the right stuff, nothing but the right stuff, and you have it right there where you need it. So the way this works is, it's basically layering caches. You've got the file system cache, which is what the device will download and keep available for you. And obviously you can configure how much you want to download and how much you want to keep around, because your disk space should be under your control, right? And then we have the server. This is, you can think of the server as the per user memory cache, right? It's a thing that's running on the device, and it has the user's data in memory, the bits that the user wants to have in memory, because they're working on it right now. And that needs to be managed. You need to flush it out to disk if you don't need it. You need to load it in when you need it. So there's this server thing that manages all of this user state. And then obviously you have applications, and even the applications want to have exactly the stuff that they need right there in memory, because they need to redraw it a lot and they don't want to go back to the server to fetch it again and again. So we need infrastructure inside the applications to manage these caches again. It's really all about layering caches. And then we try to be smart about how we fetch things and how we put them into these caches. We try to do something we call zero copy retrieval, which basically means data is coming in through the network socket, right? You get it in chunks from the network. You get little bits of data coming in at a time, as much as your network will provide you. And ideally, we should just go back out to disk immediately with that without accumulating it all in memory, right? So if you get a big email, that infamous DVD attachment that someone sent you, don't tell me it doesn't happen. So you get that DVD image, you get it in chunks, you take those chunks and you flush them immediately out to disk so you don't have that big DVD thing in memory. That's something we try and do. We're actually pretty close to achieving that. Not totally, so we still accumulate some larger buffers, but it's actually pretty slick. What we want to do, and this is something where we're still not quite there yet, we want to be able to get only the things that we actually need and to aggregate them so we don't have to fetch them again when we need them in that set again. So something like the current week, right? You want the calendar for your current week. Now, you can get all of that stuff from the calendar and then go through and figure out if it's actually in this week, but ideally you would just want to get just the bits you need. So this is as minimal as it possibly can. Now, this needs support from a lot of infrastructure. We use for our searching infrastructure Nepomuk. and the stack underneath, which is Soprano and Virtuoso, so all of the nice RDF-enabled facilities that we have, and we need to extend them to be able to accommodate these use cases and make sure they actually have the performance that we need. We do still think it's very necessary to use this and not just hack up our own stuff, PIM-specific stuff, because we think that all of that semantic richness will be what the KDE desktop is about. At least that's my personal opinion. This is the one thing that we do better than anyone else. We just need to get it right? We need to get it done. So we're heavily invested into this because we think if we don't do it, then no one else might do it, or maybe we are one big use case for this stuff, so we really want to push it and see if it will hold up.
Why don't you keep all your own stuff? I mean, all your calendar, all your contacts, they are not that big.
Well, we keep them. We keep them on disk, and we load them partially at least into the server, but the applications are not supposed to keep all of the calendar if they're just showing the current week. That would use a lot of RAM that we can use better otherwise. Right? So we're trying to be smart about how much we actually have in the application memory.
You mean that you read from Akademy to that application?
Yes, exactly. Yeah. And we do that in a search-based way. So we try and ask the server, give us exactly the bits that we need. And for that searching infrastructure on the server, we need the Nepomuk stuff. Then we have something fascinating called the entity tree model. Brainchild of our man Stephen Kelly, right over there. Right over there. What the entity tree model is, it's basically the one single application side cache in memory of all of your data. It's a mix of all of the stuff that you have. You can split it out by MIME type if you want, so you have one for email, one for calendar, but it has all the folders, all of the items, all of the things that you're actually operating with in memory, and it's extremely smart about what it gets, when it flushes it again, and how it populates it so that it's responsive and lazy and all of these things. So you don't get, I have something approaching 2,000 folders and millions of emails. If I open that account on a normal email application, it will block for minutes, right? We don't think that's acceptable, so we want something that is actually smart about how it populates things, and how it fetches things from disk. There will be a fascinating talk at the end of the day, I think, about the next thing. Well, actually, the next thing is just a random image. I hope you don't feel like this right now. No? I do tend to go on. So, what do we want to do next? We want to do a few more optimizations. We think we're actually pretty good right now, but there are still things that we would like to do better. We would like to be smarter about how we use the bandwidth. We would like to be smart about scheduling the things that we need to do. So if the latency of the connection goes up, you might not want to upload that big attachment email that you just composed and put in your drafts folder, right? You might want to do that when the connection is better. Because there are things from the user's point of view that really don't need to happen right now, right? They need to happen eventually. You do want all of your drafts on the server, but maybe not right now because you're on a train and the connection is flaky, right? So if you're not smart about that, then just pushing out all the changes one by one will lead to the pipe being clogged with a huge upload, while you just really wanted to have that one email in your inbox coming in, right? So we're still working on optimizing how we deal with the bandwidth and how we deal with the scheduling. This is actually an extremely complicated problem. And interestingly, at the last Apple Developer Conference, there were some fascinating presentations about exactly that problem. So if you want to learn about why that's hard, you can go to Apple and use their free stuff. They teach us, actually they've researched this quite intensively, and we can learn from what they've learned. So I think it's good to use that information that has been fully downloaded or passed through the library. Now ideally, you would want to do exactly that with all of the data that is coming in. You want to not copy it, just get it in as a stream, process it, and write it out. So it stays, the working set in memory stays very small. Currently, the facilities that we have don't allow for that. But we would really like to have it, right? Because it would mean that we can be very, very fast and very slick about indexing all of the information that you have constantly coming in, because that's obviously expensive, right? Uses CPU, uses battery, etc. But we want it, so we'd like to do this. We could be smarter about sharing the things. We have several applications. There's a mobile address book, there's a mobile organizer, there's a mobile email application, and they actually share quite a bit of information. Now, it would be better if we wouldn't have to keep as much state in each of the application of that shared stuff. The obvious one is the icon cache. The icon cache has actually recently been refactored in 4.5 to be shared across processes, at least on some platforms. But we would like to extend that concept and keep more of the shared state in shared memory so that the applications don't have to duplicate it. Hard stuff. the large payloads, the DVD image, right? You get that email with the large DVD image, and you want to show the email with that large attachment. Now, the cop-out would be to say, well, yeah, I'll just show an icon, right? And I don't actually load it into memory. It would be stupid. But what about like medium-sized stuff? Let's say you've got a 2 meg image. Do you think your email application should be able to show that to you? I think it should, right? It's not unreasonable to expect. So, but we don't really want to load it all from disk and get it all into main memory where it hogs up the main memory. So a smarter way of doing that would be to get the file, because it is a file on disk, and memory map it, and then allow the process to just attach to that map segment, and then we could access it right on the file system and leave the actually swapping in of the stuff we need to the operating system. Haven't done it yet. So if you're looking for a fun project, what we would like to do is we would like to sort and then keep the sort order around once we've done it once, because sorting is actually very expensive. Why is it expensive? Let's say you're in your email application, you're clicking sort by subject. Does your email application on the phone currently do that? Why do you think it doesn't? Bingo, you have to load all of the data in, right? In order to sort it, you have to compare it, and in order to compare it, you have to have it in your hand, meaning you have to have it in main memory. So you load all of the folder in just to be able to display 5 emails, the first 5, right? So that's a very, very expensive operation, which we ideally, once we've done it once, because we do want to be able to do it, would like to cache. And we would like not to cache all of the sorting, because that actually doesn't change all that much. In your desktop email application, how many times do you switch between date sorting and subject sorting a day? Never? Some people actually do switch quite a bit. That's one. People that don't have a good working search tend to sort so they can find stuff. But if you have a good search, that actually helps with avoiding the resorting. But anyhow, some people actually really do switch quite a lot. But most people don't ever switch, right? At least not within one usage session, within one folder. So if we could keep around the most recently used sorting for, let's say, the last 5 folders that you were in, that would really help a ton. And it would allow us to properly do sorting, which we currently don't quite do. We do sorting, but it's not really configurable. You can use the search index, sure. If your index actually takes care of doing that. But right now, the infrastructure we have doesn't allow me to say, give me the first 5 emails of this folder sorted by date in that range. We don't have the infrastructure, so we need to do it on the client side right now. If we, of course, that would be perfect, as I said a couple of slides earlier. If we could properly do ranged queries, then we wouldn't have to do that. At least not all of it. And then, of course, the phone is a world of wonders, and in particular of trade-offs. You have all of these resource constraints. You have to be very careful what you use the battery for. You have to be very careful what you put into RAM. You have to be very careful what you use your CPU cycles for. Because there are these other pesky things on the phone that insist on using part of the resources, like the phone application. Because it's not really useful if you have a phone that nicely shows your email, but then when a call comes in, it needs to swap out 2 gigabytes of memory, because otherwise you can't make a call, right? So obviously we have to play nice on this platform. It's on the desktop. If you're in your email application, we own you, right? We have your attention. This is what you do, right? It's different on the phone. On the phone, you switch very quickly between applications. You've got your email running. You want to write a message that then you have to get out of the subway. It happens to me every day. And you stop in the middle of writing that email, and then back home, you do something else for 2 hours. Oh, there's my email, and I continue doing that, right? So the usage patterns are very, very different. So we have to be much smarter about allowing people to be very twitchy, right? And then the Twitter generation, of course, keeps constantly switching applications anyhow, so it's not like me, I sit in front of my email, next. It's a slow process. People aren't like that anymore. I can already see my daughter running at 2,000 times my speed whenever she interacts with something, so this is coming up. So yeah, there's a lot of stuff, a lot of work to be done in this area. Finding out what people actually want is one part of it, because right now, people that make PIM applications for mobile start from the very basic assumption that people don't actually want much on a phone, right? They say, if I can see my inbox, that's good. I couldn't do that a year ago, right? Hey, why are they complaining? Well, as I said before, we want it all, so we're trying to think if there are things that we need to do better to enable people to have the full, rich experience of their PIM on the phone, what do we have to do? These are hard technical problems, but we're not satisfied with saying, we just not do that. People don't really want that on the phone, right? And there are many, many of these problems which we want your help with, because maybe some of you actually come from a mobile background. That's the bits with the fins and the sauna. So if you've worked on phones before, you know all of this, and you have a lot of experience in doing this. We are desktop people, so we're coming into this phone space, and we're thinking, it would be really nice to talk to someone who's been writing email applications on phones for 10 years. I would really like to do that. So yeah, if you have that kind of a background, I would encourage you to come help us out. So, bingo, lots of times for questions. Or we can attempt the demo again if you want to.
Demo or questions? 1 or 2 questions?